Good morning, my dear students. Welcome back to the online classes for class 9 physics. We will be dealing in today's class with the ray diagrams for image formation by concave mirror. Okay, now you must have done your basics of concave and convex mirror. These two are the types of spherical mirrors. Okay, spherical mirror is nothing but a part of a big sphere, okay, which has been polished on either the inner side or the bulging side. If it is polished on the inner side, the mirror is called convex mirror, and if it is polished on the outer bulging side, it is called a concave mirror. Okay, so in today's class we will see how images are formed with respect to the different position of the object using a concave mirror. Okay, now I'll be just giving you a brief introduction to the two types of mirror. Spherical mirrors are of two kinds. One is concave mirror and the other one is convex mirror. Concave mirror, it is a part of a sphere, okay, and if you have the outer side polished in silver, then this type of mirror is called concave mirror. That means the reflection will occur from the inner side. All right, now talking about convex mirror, you have a mirror like this, okay, and if you polish it on the inner side and you make the bulging side as the reflecting side, then this becomes a convex mirror. All right, now for image formation by these two types of mirror, there are certain rules which you should keep in mind. I'll be telling you about the rules briefly. Rule number 1 to construct the ray diagrams is that, rule number 1, I'll be taking concave mirror for today's class. Okay, if you have a concave mirror and while you construct the ray diagram, you have to be careful. This is called the principal axis. You have to use a scale to construct a ray diagrams. This is called the pole. All right, and from the pole, it's up to you. You can take 2 centimeter measurement from the pole, mark it as the focus, okay, and 2 more centimeter from the focus, that is exactly double the length, will be your center of curvature. All right, now I'll be talking about rule number 1. What happens to a ray of light striking on the mirror? Now ray may arise from an object and may come in any direction to the mirror and strike the mirror. Suppose the ray of light is parallel to the principal axis. This is a ray of light parallel to the principal axis. It will reflect and pass through the focus. This is rule number 1. So if any ray of light comes as a parallel ray to the principal axis, this ray after striking the mirror will pass through the focus. That is rule number 1. Rule number 2, if a ray of light comes from an object in such a way that it crosses the center of curvature and strikes the mirror, now on striking the mirror, it will simply retrace its path. So this is rule number 2. A ray of light passing through the center of curvature, on striking the mirror, will retrace its path. It's easy, right? Now coming to the third rule, if a ray of light crosses the principal focus and strikes the mirror like this, okay, then it will come back as a parallel ray. So it is just the opposite of the first rule. In the first rule, the ray was coming as a parallel ray and was passing through the focus, but in this rule, it is initially crossing the focus and then coming back as a parallel ray. You have to note the direction of the rays. All right, now there is one more rule, that is rule number 4. If a ray of light strikes the mirror like this, making a certain angle of incidence I at the pole, then it will come back like this, okay, it will simply reflect, making an equal angle following the law of reflection of light. Angle of incidence is equal to the angle of reflection. So if a ray strikes the pole with a certain angle, it will reflect back, making an equal angle with the principal axis. So these are the 4 rules which we should keep in mind while we do the ray diagrams for image formation by a concave mirror. Alright, let's start. Now, say you have a mirror, concave mirror, polished on the bulging side, reflecting side is the inner side. You draw the principal axis. Okay, now from here, from the pole, you take 2 cm or 3 cm, it's up to you. We mark it as the focus, and from the focus 2 more centimeter or 3 more, that means equal length here. This is called the center of curvature. Okay, now on this line we are going to keep the object at different positions starting from infinity. So the first object to construct the ray diagram will be kept at infinity, and we will see how the images will be formed when the object is first at infinity. Then we'll slowly shift it to this side. That means second case, object will be here, that is beyond C. Okay, third case, object will be kept at C. Fourth case, object will be kept between C and F. Fifth case, the object will be kept at F, and in the last case, that is sixth case, we will be keeping the object very close to the mirror, that is between the focus and the pole. So if you notice, we are gradually shifting the object from infinity towards the mirror, and we will see how the images will be formed. Alright, so let's start with case 1. When the object is at infinity. This is our first case. So we have kept the object at infinity, and one thing to be noticed here, whenever the object is kept at infinity, the rays are always parallel to each other. So let us take 2 rays. Okay, we need to take at least 2 rays to construct any ray diagram. Ray number 1, since they are coming from infinity, we cannot trace where the object is, so we will just be showing the rays. According to the rule, a ray of light parallel to the principal axis has to cross the focus. So this is the incident ray and this is the reflected ray. Another ray, since it is coming from infinity, it has to be parallel to the first ray. Okay, and again, since it is parallel to the principal axis, it has to cross the focus. Now you have to mark the location where the 2 reflected rays are meeting. Where are the 2 reflect? This is reflected ray number 1, this is reflected ray number 2. Where are they meeting? They are meeting at the focus. Okay, and they are meeting, just making a dot here. So image may be very big, but object may be very big, but the image has become very, very small. So what are the characteristics of the image here? Characteristics of the image. It doesn't look parallel. Let me make it parallel. Characteristics of the image when the object is at infinity. Now since the rays are actually meeting at a point and crossing each other at a point actually, so image is real. Now you should know that real image is always inverted. So the nature of the image formed by a concave mirror when the object is kept at infinity is that the image is real and the image is inverted. Talking about size, so these 2 are the nature. This third point talks about the size. Now size, it looks very small if you compare the sun. Okay, the sun is very big but the image is very, very small. So image is very small. So it has been highly diminished. Alright, and the fourth one talks about the location where the image is formed. If you look at the diagram, the image is formed exactly at the focus. So image is formed at the principal focus F. So this is how image is formed when the object is kept at infinity. Now let's proceed to the second case. As I told you, the object will be coming closer to the mirror now. Okay, so when the object is this is F and this is C. Okay, Now when the object is kept beyond C, now first case we were at infinity, second case we are coming closer, so the second point here is beyond C. So we can make the object now since it is very close to the mirror. Alright, we will take one point, the tip of this arrow which is used as the object. I will name the arrow as AB. Take one ray from the tip, make it parallel and make it reflect. It crosses the principal focus. Alright, now the second ray, you may take it like this. Okay, crossing the focus. After reflection, it has to come as a parallel ray. Now you can see this is reflected ray number 1 and this is reflected ray number 2. They are meeting somewhere here. So I will name it as A dash B dash. This is nothing but our image. So if this was the object, this becomes our image. Alright. Now if you look at this image, we can easily write the characteristics. The rays are actually meeting. So characteristics of the image, it is real. Alright. Now it looks ulta, right? It is inverted. Okay. And we can't say it is highly diminished, but we can say it is diminished, isn't it? If you compare the size of the object and the image looks slightly smaller than the object. So it is not highly, but it is obviously diminished. Alright. And lastly, for the location, where is it formed? This is F and this is C, so the image is formed between C and F. So it is not formed at F, but it is formed between C and F. So these are the characteristics of the image when the object is kept beyond C. Let's quickly proceed to the third case. Okay, in the third case, we will just shift a little to the right. That means we will keep the object at C. Let us redraw the diagram. And it is not beyond C now when the object is at C now. You draw this mirror. And while you are doing it, please do it using a scale and a pencil. This is the pole. This is the focus, exactly the same length. We might go wrong because we are using freehand diagrams here. This is the center of curvature. Okay, now we are placing the object here. Name of the object is AB. This is interesting now. Okay, now ray number 1 parallel. It has to cross the focus. Alright, ray number 2, I can take the same convention as I had taken in the previous diagram. If it is crossing the focus in the beginning, then it will come like this. Okay, and the image is formed exactly here. Okay, so the name of this image is A dash B dash. So did you notice something here? They are formed, that means the image is formed at the same location where you had placed the object, and if you use a scale, you will see that both the image and the object will be of the same size. Alright, now coming to the characteristics of the image is real, that is alright. Secondly, image is inverted, that is also alright. Okay, now as I told you, they are of the same size. That means in this case, image is not diminished, but it has become a little bigger, coming to the same size as the object. And talking about the location, where is it formed? It is formed exactly at C. So the object was placed at C and the image is also formed at C. So the location of the image is at C. Alright, so if you place the object at the center of curvature, image will also be formed at the same point, that is the center of curvature, and the size of the image will also be the same as the object. Okay, let's quickly proceed to the fourth case. Okay, Now you draw the mirror, principal axis, F, C. Now we are going to place the object inside C, but before F, that means somewhere between C and F. Okay, name of the object is A, B, ray number 1. Okay, the first ray, which is parallel to the principal axis, will pass through the focus. This is not a problem. Okay, second ray again, let it cross the focus. All right, now it will come back as a parallel ray. Okay, now where are they meeting? I'll just mark it here. Now this is A dash, B dash. Now here you can see that object has been slightly shifted towards this side, that means beyond C, and the nature remains the same. It is real, the rays are actually meeting, it is inverted, okay, and it is not the same size as the object. It is, if you measure it using a scale, or if you just have a look at the image, it has been magnified now. Now you can see that slowly as the object is getting closer, image is getting magnified. Okay, now where is it formed? You can easily see it is formed beyond C. So where is the image formed? It is formed beyond C. So these are the characteristics of the image when the object is between C and F. Alright, now we have finished with case 4. Let's quickly go to case 5. Let's see where the object can be kept now. Okay, pole, focus, center. Now the previous case the object was here, now we are going to shift towards the right side, that means object will be kept exactly at the focus with the name AB. Ray number 1, it will cross the focus like this. Okay, now ray number 2, since we cannot make it cross the focus because the object is already kept at the focus, we will make it look as if it is crossing the center of curvature, passing the tip of the object like this. Alright, now if a ray of light crosses the center of curvature, according to the rule, it will just retrace its path like this. Alright, so this was ray number 1 getting reflected and this is ray number 2 getting reflected, and we can see that if you keep on extending even till infinity, they are never going to meet, and two lines which are parallel to each other, it is said that they meet at infinity, that means the image is also formed at infinity. Alright, so nature of the image, real, we assume they meet at infinity. Secondly, if it is real, it has to be inverted. Okay. Thirdly, it is not only magnified, but it is highly magnified. Okay, and where is the image formed? We can't see trace where the image is formed, so we say that it is formed at infinity. So whenever you place the object at the focus, the image formed is very big and it is formed at infinity. Let's move on to the last case for today's class, case 5, when the object is at F. Okay, so this is the diagram. Now coming to case 6, obviously now we will be shifting inside the focus when the object is between focus and the pole. Okay, we will draw the mirror. I will draw it little lower here, you will come to know later why. Then Let me extend it a bit. The pole, focus, center, object is here, AB, okay. Ray number 1, parallel, it will obviously cross the focus, not a problem here. Ray number 2, like we had taken in the previous case, we can't make it cross the focus, but we can make it look as if it is crossing the center of curvature, like this, okay. Now if it is crossing the center of curvature, it will retrace its path along the same line, okay. Now this side they can not meet because they are diverging out, but if we produce them backwards, they are going to meet somewhere behind the mirror. But since the rays are not actually meeting, they are appearing to meet. We don't call it a real image, we call it a virtual image. The name of the image is A-B-, but here you can see that image is erect or upright. It is not inverted as it was in the previous cases, it is now erect, okay. Now characteristics of the image, there is a change in nature now. It is not real since the rays are not actually meeting. The ray image is virtual, and virtual image is never inverted, it is always upright or erect, okay. Not highly, it looks magnified, but it is not as huge as in the previous case. So image is just magnified. And image, where is it formed? It is formed behind the mirror. So we can say that image is formed behind the mirror. Alright, so these are the 6 cases for the different positions of the object with respect to which we have learned how to construct the ray diagrams for the image formation, okay, and we have also learnt about the characteristics of the image formed by a concave mirror. In the next class, we are going to deal with the image formation by a convex mirror. Thank you for your attention.